Okay, this is the second video, and again, I've sketched this up, and I apologize for not being the same as in class, but what with the life of the American teenager going on upstairs, I'm going to get this finished and get it posted out. So you start to see it in terms of layering here. I've got dimension going on. I've got a couple of different, so let me go ahead and list that. That's force applied, and now I might want to say, boy, force applied X, force applied Y. So I learned to do things like this. I go to my isolate layer. I'm sorry, we go to my isolate layer here, and it'll isolate that. And these are not all, these are actually force reactive. So I might want to grab these two here, these two, that one there, and I might want to change it to force reactive, also in green, and that's gone. And then I also might want to do this. Well, I want another layer, so I'm going to go LA for layer, or minus LA. I'm going to go to my force applied, and I'm going to say, boy, I want to make a new layer out of that. So I'm going to make a force applied, and in the end, we'll see whether we can actually see this. Way too many toolbars. Don't like the fact that those stick around. I want to make a new toolbar and have it called force applied. Turning else force underscore applied underscore X, and then of course make a new layer, force underscore applied underscore Y. And I'll maybe make this one looking a little different. I'll make it in yellow. And so when I go here and back to closing this out, I can grab my Y, 1, 2, 3. We could do it all kinds of different ways. Learn to play around with the quick select. It really starts to build you into all the different things you can do when you start thinking about. But my Y applied forces in the Y direction, again, they're shown as positive. I grab each of these. I learn to right click, go to properties, and change the layer to force applied Y. And then once I do that, I can more or less go ahead and say I don't want that one around anymore. I'm going to get rid of that, freeze it out. I can now grab each of these and change them, if I would, now to force applied X. So now I've got two sets of layers, applied X and Y. Learning to turn minus LAT for star for on and thaw star. T star on star. I'm sure there's a better way to do that. We now start to see where we're at and what you were to do then when you think about it. And it's a little bit different here, is to determine the reaction at every force. And I'll just do it at force D right now. Okay, so you're going to realize what the goal was. In this stress here, you got 1, 2, 3. A lot of these are a little bit more solvable than stuff you might have seen. But at point D, what is the reaction at A and at I to a unit force in the Y direction at point D? And I'm kind of zooming around here. Well, basically, these are 5.25 going across. And we know that this is going across here. I'll do another dimension. You can learn to do this. Click on that, set your current dimension there, and go to the dimension, which is the overall one, from the end there to the end there. And we have, in effect, you see that 42 feet. So if we think about the reaction at D to a unit force at point D is going to be the distance from the other support, which is 42 minus 5.25 times 3. So it's going to be more on this side than on the other side. And then we can do the same to determine the reactions. I'll pause here and figure the same out and put down some numbers here at A and I, which are going to be, in this case, in a negative direction, down. I'm going to pause here and calculate. So in this case, my reaction at A to a unit force at D is going to be minus 0.625. I'm going to do a line from the end point there. Zoom in there, a line from the end point there. Going down, turning on my F out, 0.625. What changed last? Property layer. Don't want to do that. Change this. Oh, well, at this point, boy, that stuff's getting in the way. What do? You freeze that out. It's the current layer, which means it probably was something underneath. So I'm going to go ahead and go to my layers here. Change this very often 0. It's not a bad one to leave around on layer. We've got that, which allows me to go ahead and freeze using this toolbar right there. Freeze the dimensions because they do get in the way. I'm going to change my current layer to force reactive, and I'm going to take and do a line from the endpoint there. Turn on my F8, and I'm going to go 0.625. That's my reactive force to this one single one here at D, 0.625 in that direction. And so in here it is in fact a line from the end point of here. Undo. Setting that up as 0.375. Line from the end point of here. Got my ortho on 0.375. Now, if you've got a question on how we went about in getting these reactions, they have to, the sum of that force and this force and the force in the y at D all has to be 0. So I'm going to go ahead and just leave for this rest of it. I'm not going to ignore the rest of the forces now. I'm just going to be looking at the forces at D. So what I can do is I can start to do things like this. Freeze that up. Freeze this up. And I can just start erasing out everything, or layering if you would, but I'm just going to erase out because I'm just E window, erasing everything out except for that which I'm interested in. And that what I'm interested in is actually not this, and it's not actually this. This is the effect, and I'm going to actually even erase this one out for now. I'll leave that one around. This is the effect of that force. A force of 1 at D is going to cause a down force of 0.625 and a down force of 0.375. And so we're finally left with trying to determine, in effect, I'll turn the members on now if I go back to my layering. There's all my members, and so we talked about, I think, figuring out the forces in this one, and this one, or thereabouts. And so this is where, in effect, you can do this. Wipe out! And we'll go ahead and go from there to there, to there, to there. And it's really a great one to say now, frames, wipe out, frames, off. And now that looks pretty sweet because in the end what your point was, this is actually going down. I'm going to draw off a little bit of squiggly on here so you can see that this is going down from the end point here. And you were to look at F8, the effect of a single force, right? That's not good. Undo. Y isn't good because I got my snaps on. My snap was on the node, but I just want to kind of show you that there's a visual right there of 1 unit. Now, when we see the frames are off, all of a sudden we realize that we can draw a little circle at the intersection. As we get it with here, you'll see it. There's my circle there. And I think at this point you realize there's a force and tension here and a force and tension here. And I think also you can go to your layers here. And I don't see probably comps moment arm. I can draw a line from the center of this perpendicular to the line of force of this force there. I can also draw a line from the center of this to the perpendicular to my force here. I'm sorry, to the perpendicular to doesn't snap too good for me. We're going to try it again. This little line here. We're going to go a line from the center of this to the shift right click perpendicular to that, and it is not finding it. It's kind of odd. There it is. And so what do you have? Well, you know that if this is pulling down this way, this has to push. In other words, this is pushing down, has to push back. It's based on a ratio of that, and so for that force applied at D, we have a ratio of 21 to, there it is, 7 in my case. It was 10.5 in yours, so this is going to be 3 times the 0.375. So I'm just going to do that. Boy, that's wrong. That was 0.375 coming down. So 3 times that. So I'm just going to draw a line. If you remember, I'll just do it from now, from the end of this. I'm going to draft it at 0.375 angle 0. And then I'm going to scale it up 3 times its compression. I hope that gets in the 11 minutes. That's how you calculate this and do it for every individual joint. Thanks for listening.